Okay, this is the fourth section of topic 1, and now we're going to look at a hexagon. The hexagon has 6 sides. Let's label our parts of a regular hexagon. So this is a side, this is the center. The line that connects the center to the vertex point is called the radius. And the line connecting the center point to the midpoint at a perpendicular is called the apothem. And those are in words you need, especially apothem. Apothem is going to be the one that tells you the side length. Now, just like in the square we had a special right triangle, the hexagon is also a special right triangle. I think I'll draw another radius over here to help you understand that. If you notice, what I've drawn here is an equilateral triangle. So that happens every time you draw a radius. Trying to make it look good. When you draw another radius, you do have an equilateral triangle where you have 60 degrees in each corner, and then the apothem is going to take this one and divide it into half. So you end up with two 30, 60, 90 right triangles. So this is pretty important. You're going to need to remember that. Let's just sketch over here in the corner. You need to do this with me just to help you remember. On a 30, 60, 90, the short leg is always opposite the 30 degree, and we're going to call that x. The long leg is always opposite the 60 degree angle, and it's x times the square root of 3. And that just means you're going to take whatever your short leg is and multiply it by the square root of 3. And then the hypotenuse is always opposite the right angle, and it's just double whatever your short leg is, so 2x. And this works for any right triangle that has a 30, 60, 90. We're going to be using this a lot to find missing side lengths, so make sure you understand this. If you don't, come see me and we'll talk more about this one. We're going to go through some examples. You're going to start using the 30, 60, 90. Starting with this first one. See how they're giving you the apothem, and you've got to figure out a side length, because the only way to get the perimeter of a hexagon is to know that half the side length, we can then double it. Now on the square, remember we were using whatever the apothem was, that's what the side length was, half the side length. Not on this one. Since this is a 30, 60, 90, this 4 times the square root of 3 represents our long leg. So if you divide out the square root of 3, that means your x is just 4. So that's your short leg. Let's go ahead and label it. 4 would be half of the side length. So if half of the side length is 4, I'm going to go ahead and show you that means that all the sides are going to be 8, because you're just going to double whatever the side length is. I think I'll go ahead and tell you that you're going to notice that every time you look at a hexagon and you double this short leg here, you're not only getting the side length, but you're also getting the radius. Let's go ahead and label our radius. These are always going to be the same. We're going to kind of notice that each time we work these, but it'll help you later on. Okay, the perimeter. This time we're going to take whatever the side is and multiply it by 6, because there's 6 sides to a regular hexagon. So the perimeter of this one's going to be 6 times 8, which is 48. So 48 centimeters is the perimeter. We're going to have to use our regular polygon formula, 1/2 perimeter times apothem. So on this one they gave us the perimeter is 48. The apothem is 4 times the square root of 3. Because we're going to leave our answers in radical form, the square root of 3 will remain a radical. Just multiply 1/2 times 48 times 4. And when you do that, you get 96. So 96 times the square root of 3, and remember area is in square units. So when you label it, make sure you put a little exponent of a 2 on your unit centimeters. That's example 1. Alright, example 2. On this one, the apothem is 6. And remember, let's write our formula. To be able to get perimeter, 1/2 perimeter times apothem. To be able to get the perimeter, we're going to have to use our special right triangle, our 30, 60, 90 triangle. And this time we know the one that's opposite the 60-degree angle, so we know the one that's represented as this short leg times the square root of 3. So since that's 6, we're going to have to again divide by the square root of 3. Okay, we're going to have to practice rationalizing a denominator here because this turns into 1, but this right here, if you were to type that in the calculator, you'd get a decimal. So let's avoid decimals for a while. Let's just write our answers in radical form. So you have to rationalize the denominator. I think I want to write those words so you'll remember when I say it. Sometimes it's good to write some words in your notes to help you remember what you're doing. Rationalize the denominator. That is kind of a fancy word, but it just means to remove the radical in the denominator. You always use whatever the radical is that you're trying to remove as a value of 1 here. So 6 times the square root of 3 divided by the square root of 9, because 3 times 3 is 9, but that's a perfect square, which is just 3. So you get 6 times the square root of 3 over 3. This is still not simplified because the coefficient 6, you can divide by the denominator 3 and get 2. So keep 2 as your coefficient. 2 times the square root of 3 right here. This will be your short leg. And that was kind of a lot to do just to figure out the short leg, but we had to get that because that piece is half of the side. So if 2 times the square root of 3 is half the side, then I'll just put a little grouping symbol. If we double a 2, we get 4. So 4 times the square root of 3 would be our side length. So the perimeter here, if 4 times the square root of 3 is one of the sides, if you labeled all of them 4 times, I think I'll do that. If we label them all 4 times the square root of 3, you're just adding 4 times the square root of 3 6 times, or you're multiplying 6 times 4 times the square root of 3. I kind of ran into this, so be careful. The actual perimeter here, 4 times 6, is 24 times the square root of 3. So that is your perimeter. To find the area, we're going to do that perimeter, 24 times the square root of 3, times the apothem. Remember, the apothem is this line right here. That's 6. Again, let's practice leaving it in radical form, so you're really just taking half of 24, which is 12. 12 times 6, and then kind of ignore the 3. 12 times 6 is, let's see, where am I? 72. So 72 times the square root of 3 is your area. Kind of tricky on that one, having to rationalize the denominator. That's not always what you'll have to do, but anytime you're dividing by a radical, you will. Alright, look at example 3. Find the indicated measures of this regular polygon. Okay, this one starts out a little bit easier because 12 is the side length. It's a regular polygon, so all the sides are 12. The perimeter is just 6 times the side length, so 6 times 12. 6 times 12 is 72. So your perimeter is 72 centimeters. Okay, remember this line right here is our apothem. If you know that 12 is your side length, then 6 has to be half of that side, this piece right here. And we have a 30, 60, 90, so if we multiplied that short leg times the square root of 3, that gives us the angle, the side across from our 60-degree angle. So this one ended up being a little bit easier because we know the apothem and the perimeter pretty quickly. The formula for, let me write that on here. The formula for area, 1/2 perimeter times apothem. So we're going to multiply 72 times 6 times the square root of 3. So you're really multiplying 1/2 times 72 times 6. Leave the square root of 3 as a symbol. 1/2 times 72 times 6 is 216. You can use your calculator, multiply those out. So 216 times the square root of 3 square centimeters would be your area. Okay, looks kind of like number 4 is very similar to number 3. The only difference is we have a different side. So this one's going to deal with some decimals because 21 is an odd number when you divide an odd number by 2. So 21 divided by 2 is 10.5. I'm going to kind of write it small, but 10.5 would be this piece half of your side length. So that's your short leg of your 30, 60, 90. So just like on number 3, the example 3, you do the short leg times the square root of 3. That is your apothem. It's kind of a funny answer to have a decimal with a radical, but you can do that. So that's your apothem. The perimeter on this one is just 6 times the side, whatever your sides are. This time it's 21. So 6 times 21 is 126. So 126 inches is your perimeter. Your apothem is 10.5 times the square root of 3. And let's see, the area on this one, let's go ahead and write out, let's show our work. I know you're doing a lot of these in the calculator, but it's a good idea to, especially when you come back and look at it later, so you'll remember what you were doing. It's always a good idea to write down the values. I always usually start with the formula and then replace the values underneath it. I am going to leave it in radical form, so the square root of 3 will not be used when you punch this. If you want to do all this in the calculator, you can. Just make sure when you type it in, just type in 1/2 times 126 times 10.5. This is a pretty big number, but it's 661.5 times the square root of 3. Don't leave the radical 3 off. It'll be wrong if you don't. So it's 661.5 times the square root of 3. I think I'll just show you, if I were to put it in the calculator and type in times the square root of 3, oops, nope, I'll have to do that later. I got to get some batteries. Times the square root of 3, you'll get a decimal answer for that one. Okay, also I'm kind of running out of room, but I want you to notice, and hopefully you left some room too. I want you to write this at the bottom. Notice that the side and the radius of a regular hexagon are always the same. And let's kind of look at what that means. Notice that the side and the radius are always the same. So if you look at, I know we didn't label the radius on these, but if we did, if we took 10.5 and doubled it, we'd get 21. Wasn't that the side length? And then go back up here. If we took the side 6 and we doubled it, we get 12. That's the radius. Well, that's also the side length. So it's kind of an interesting fact. In fact, let's use that for the next two. Let's go to number 5. See how they gave you the radius this time? And if the radius is 7, that means the sides are 7. So what's the perimeter? Perimeter is 6 times the sides, so 6 times 7. When you multiply 6 times 7, you get 42. So 42 centimeters is your perimeter. Alright, a 30, 60, 90 to get the apothem, we first have to get this side length. Now remember, the side is always, the apothem always bisects the side. So if you have 7 as your side length, half of that is 3.5. So 3.5, I'm going to go ahead and label it. 3.5 would be half of a side. And then the short leg is always times the square root of 3 when you want to figure out the apothem. So there's our apothem. 3.5 times the square root of 3. So we have the perimeter, we have the apothem. We can use the formula 1/2 perimeter times apothem. So it's 1/2 42 times 3.5 times the square root of 3. I'm going to leave it in radical form, so the square root of 3 stays a radical. If you multiply 1/2 times 42 times 3.5, you get 73.5. That's your area. 73.5 times the square root of 3 square centimeters. What was the apothem? 3.5 square root of 3. So see how each time you use this formula, you're always going to have to figure out the perimeter and the apothem, and that's how you figure out the area. Okay, let's try the next one. Let's kind of use our rule again that if we know the radius, we know the side length. So one of the sides here would be 10.2. So the perimeter would be 6 times 10.2. Oh, I left off. I'm sorry, not 0.2, square root of 2. I can fix that. So if 6 times 10 times the square root of 2, that would just be 60 times the square root of 2. So that is your perimeter. To get the apothem, we're going to have to do, first of all, it's always half the hypotenuse to get your short leg. Now notice on number 6 they've drawn the apothem going up. I don't think we've talked about this yet, but your apothem can be drawn from the center point to any side that's perpendicular, that bisects it at a perpendicular. It doesn't have to be the one at the bottom. It could go to the side or to the top. So this time they drew it to the top. So if we know the hypotenuse is 10 times the square root of 2, half of that would give you the short leg. And to get, now this one's going to be a tricky one, because to get this long leg we have to take this short leg, 5 times the square root of 2, and multiply it times the square root of 3. Now I don't remember if we've talked about this, but the square root of 2 times the square root of 3, let me write that over here. I'm going to put the apothem is the short leg times the square root of 3. Anytime you multiply radicans, you just multiply the 2. So it's 5 times the square root of 6. We're going to leave it in radical form, so that's 5 times the square root of 6. Okay. 1/2 perimeter times apothem. Your perimeter is 60 times the square root of 2. Your apothem is 5 times the square root of 6. Now, we can do this in the calculator if you want to, and if you use the radicans, the radical signs and the numbers, you're going to get a decimal. So let's leave it in radical form. And remember, because we're just multiplying, you do multiply the 2 and the 6 for your radical. And then the 1/2 60 times 5, well, 1/2 of 60 is 30, and 30 times 5 is 150. So now this is actually not simplified, because the square root of 12, let's talk about that for a second. The square root of 12 can break down into the factors 4 and 3. And if you remember, the square root of 4 is a perfect square, and the square root of 3 is not. So since the square root of 4 is 2, 12 can be written as 2 times the square root of 3. And then that times 150, remember, you just multiply the 2 times the 150, so that's going to be 300 times the square root of 3. You know, on one like this, it's kind of lots of radicals and simplifying. I would allow you to use a decimal. If you wanted to, even up here, turn it into a decimal, I would allow that. Come see me if you have questions about that, but I would allow a decimal on one like this. They didn't put a unit, so we'll just leave those off on this one. Alright, last one. If you want to borrow my template to help you draw the hexagon, you can. I don't know, I like to have a picture. I think it makes it a little bit easier to work the problem. Let's draw our apothem and our radius. Okay, 48 is the perimeter, so they've already given us And remember how the perimeter is 6 times the side length? Well, this time we're going to have to divide 48 by 6 to figure out the side. So on this one, our side would be 8. I'm going to go ahead and let's label a side up here 8. So we already have the perimeter, we just need to find the apothem. If the side is 8, that means half of the side is 4. So our apothem has to be that short leg times the square root of 3. So the apothem is 4 times the square root of 3. Using the formula, 1/2 perimeter times apothem. We have a perimeter of 48 and an apothem of 4 times the square root of 3. When we multiply it, let's leave it in radical form. We're going to multiply 1/2 times 48 and then times 4. That ends up being a 96 times the square root of 3. So 96 times the square root of 3. This one is labeled in centimeters, so we can give it a unit, square centimeters. Don't forget square when you're doing area. Okay, that's it. Come see me if you need some extra help.